So it's 10 o'clock. Thank you all for joining. Joining our California Native Plant Society San Gabriel Mountains chapter. We have a special meeting tonight. We normally don't hold program meetings in July and August, but we had a full topic tonight about our fire risks and it was pertinent information we wanted to make sure to get out to everybody. So thank you all for joining you. Um, First, I'd like to start off with our land acknowledgement, just to acknowledge that our chapter, the California Native Plant Society, recognized that we occupy land originally and still inhabited and cared for by the Quiche, Tongva, Tataviam, Saran, and Chumash peoples, and pay respect to the elders and descendants as they continue their stewardship of lands and waters. We acknowledge that settler colonization resulted in land seizure, disease, subjugation, slavery, relocation, broken promises, genocide, and multi-generational trauma. This acknowledgement demonstrates our responsibility and commitment to truth, healing, and restoration, elevating the stories, culture, we are grateful to have to live in these ancestral lands. We are dedicated to growing and sustaining relationships with native peoples and local tribal governments. I also want to just put out the disclaimer that the Eaton Canyon natural area, which we historically have, um, we have still have events going on in the summer. Here's tonight. We have habitat care at Santa Fe Dam. Although the third Saturdays and fourth Fridays of each month. So that's something, if you want to come out in the summer, you're welcome to join us. We have a plant walk this Sunday at Ascot Hills, plant walk and nursery tour. So thank you, Dave, for putting this together. Also in conjunction with um, CMPS chapter. Then we also have one of our local landscape architects is doing a lasagna mulching and hugel culture workshop in Altadena. So that's Studio Petrichor, Pollyanna. They do some sustainable native plant local landscaping. Um, there's one more thing I want to talk about. It's an event that just came our way. Um, the hunt for Hartwig's iris, southernmost occurring subspecies of Pacific Coast native iris. Jeff Chu, who's vice president of the California Native Iris Society, um, is talking about that, and that will be on August 5th. Talk to Jeff Chu. If you are interested, he will send you a link to that. And that's all I have. Thank you all for joining us, and I'd like to turn it over to Dave Coons, who will introduce our speaker today.
Thank you,
Dave,
Roger.
take it
I'm
away.
sorry for the technology issues.
Yeah.
Everybody, thank you very much. Dr. Francisco Escobedo has been very kind to come today and talk to us. I want to thank a few other people, Diana Nicole, as well as Robin Smith, who's coming on soon. Both of them, all three of them have been working together, and we very much appreciate you coming today. Uh, Dr. Escobedo is a research scientist with the Forest Service. He has well over 250 scientific publications to his credit. He's been studying environmental sustainability and the resilience of socio-ecological systems, say that twice, such as urban and community forests and the urban wildland interface. So today he's going to come and talk about some of his research he's doing. I think if you see in the chat, he's going to stop around halfway through. Please put your questions in the chat so that Diana can help gather those together. And then we'll also have some more complex discussions at the final end. So without further ado, Doctor, may I allow you to start?
Thank you, but I need to be co-host, so I've just been unassigned, so I can't share my screen. But
I will get that. Hold on.
all right. Well, thank you. Thanks for the opportunity to speak to you all. What I'll try to do in this presentation is talk a lot about the research that we've been doing for the past couple of years. A lot of the research is going to be focused on urban ecosystems and urban forests and the wildland urban interface. And as we get into the discussion, I think it's really important to separate out urban ecosystems from chaparral ecosystems, urban ecosystems from forested ecosystems, because I think that's led to a lot of the lack of ability to communicate among different groups who've been a part of these discussions around Zone 0 and defensible space zones. All right, so I'll start now. So let's see. So let me get right into it. And all these issues and background will be developed in the will come out in the presentation. So one thing I'll do is I'll present for about 25 minutes. We'll take a pause in the presentation. I'll respond to some of your questions, and then we'll get into the second half of the presentation. A little bit about myself. I started off as a firefighter in New Mexico and Arizona. I spent some time here in California. After I graduated, I was a soil scientist and a forester with the Forest Service for several years in New Mexico, Arizona, California. I worked in Alaska for a bit. My master's is in watershed management and fire effects, but my PhD is in policy and economics. And I worked for several places in the Forest Service. And then after I got my PhD, I went to the University of Florida and I was a professor of urban and community forestry for 10 years. And then I went to South America and I was a professor of social and ecological systems in a biology department, basically teaching kids on how to think about people, sustainability, big picture things, and problems beyond flora and fauna. And 6 years ago, I came back to the United States and I landed in this job where I'm now a research social scientist. However, since I have a background in fire, forestry and soils, and policy and economics, I tend to use different methods and approaches, and I work with different disciplines to try to address problems in this space between cities and natural areas. And in that little box in the lower left, you see a bunch of titles that fire folks will recognize. And the reason I'm showing this is not to say that I kind of lord over this topic, but quite the opposite. That even despite almost now 25, 30 years of working in this space, I don't consider myself an expert on this topic because it's a very new problem we've run into. And there's a lot of information we need. So a lot of the research I've been doing, collaborators have been doing, is trying to provide information to kind of address these unknowns. Okay, so as I said, first half we'll talk about the background, the problem we're having in terms of urban vegetation, homes, and fire, differentiate between cities and natural areas, communities and plant communities. I'll give you some research that has kind of laid the foundation for a lot of the current research we're doing that's very relevant to this Zone 0 issue that you all have heard of, and some of the research we undertook immediately after the LA fires in January of 2025. But this background research we started 6-7 years ago, and it all kind of came to a head with what we've been experiencing here for several past years of communities being affected by fire. Before I start this presentation, a couple of years ago, I read this book by Mike Davis. I'm sure a lot of you have read it. And I thought this little comment and text really kind of frames the problem then that we'll be kind of diving into. California, often to its own surprises, has developed a style of urbanization that not only amplifies natural hazards, but reactivates dormant hazards and creates hazards where none existed. So I think that's going to be the central premise of a lot of what we talked in, okay? That it's just not a fire issue. It's just not a buildings catching on fire issue. And it's not just a plant issue. It's also a human issue and a societal issue. And they've all kind of intermixed here in this space where we've been seeing this problem, okay? So this is how I've approached this problem with these recent discussions around zone 0 and defensible space zones, often known as home ignition zones. And we started thinking about this a couple of years ago after Paradise, Santa Rosa, the Woolsey fire, that fire that was affecting these communities just wasn't fitting the models and the way we were thinking about fires and the way we were responding to fires. And this is how I think about this problem, okay? So up to now, we've been thinking about wildland urban interface environments, and we've been thinking about the urban environment, okay? And you see that line right down the middle. I think that line is very emblematic of how the information we have, the technologies we have, even the vocabulary we have falls in line with both of these ways of looking at this gradient that goes from natural areas to cities, okay? We approach things either from an urban context or from a wildland urban interface context. So what do we mean by this wildland urban interface? So I'll give you a specific definition in a couple of slides, but this concept has been around now for several decades, and it's been really ingrained in foresters, wildland firefighters, structural firefighters, mechanical engineers, and there's all sets of research, guides, terminology, ways we go about of managing fire, responding to fire, that this concept and these lines of thinking have really been ingrained in us as land managers, firefighters, urban foresters. So what you'll be seeing here and what I'll be arguing is that when we're now faced with neighborhoods that are highly populated, highly urbanized, when they're affected by fire, we bring in this body of knowledge that we picked up from working in wildland areas, natural areas, or from buildings catching on fire, materials catching on fire. However, as we all know, nature in and around cities and in our yards is very different and doesn't really conform to these ways of thinking about ecosystems, okay? So when we look at the wildland urban interface with regard to how we manage vegetation and fire, I'll ask you to focus on those 4 tiles. You'll see that in these environments and these landscapes, there's more vegetation than buildings. Vegetation often surrounds buildings for large contiguous areas. Our experience has shown that fire behaves a certain way and that it's continuous. It spreads from vegetation types to vegetation types, from fuel types to fuel types, and it catches things on fire. And because these communities that we've dealt with in the past are in large tracts of land surrounded by natural areas that county, state, federal organizations manage, it's a lot easier to manage that vegetation, okay? So that's the reality that we're working with when we talk about wildland urban interface. There was a concept, a model that was developed 25, 30 years ago by Jack Cohen, who used to work in the same office here in Riverside, that came up with a home ignition zone, which is later known as a defensible space buffers, and is most recently being referred to as zone 0, 1, and 2 here in California. But basically the premise of this model is that an individual home can remove vegetation in its proximity and thereby mitigate the probability of that building igniting. And this model in its time and currently, it really makes sense. And what it does, it focuses fire reduction mitigation practices on the home as opposed to the entire landscape. So what this model argues is that why try to clear cut a mile around every home when common sense and what our experience shows is it's those immediate zones around the home where vegetation needs to be managed, okay? So you have the zone 0, which is from 0 to 5 feet, which they permit all vegetation be removed. We'll talk about that later. And as you start getting further from the home, you keep some vegetation, but you remove densities, again, to stop that continuity of fire that spreads from the landscape to the home. One thing to keep in mind as we discuss this defensible space zone, this model was developed in wildland-urban interface, exurban, rural environments, where homes have generally 1/7 of an acre around them so that they can implement those zones. Folks living in those types of homes are a certain demographic, they have a certain type of education level. So it's been a very practical way of dealing with vegetation. In fact, the name defensible space zone was originally meant as that's a way that provides firefighters access into your home, into your yard, so they can then defend the home, okay? So now it's being applied to urban areas, and we'll talk about that a little bit later, okay? So again, this concept's been around since 1999, and it was started by Jack Cohen. On the other hand, when we talk about urban landscapes and urban ecosystems, again, from a Forest Service perspective, I think we've done a very good job of informing folks about the vegetation, about the benefits of vegetation, and about the benefits of planting trees for shade, for air cooling, for habitat, for property value increases. But a lot of this information comes from the eastern United States, where it's greener and it's not as fire prone. Okay, so we treat vegetation as a source of ecosystem services or benefits to society. But when we're in the urban environment, as those 4 tiles show, in these urban environments, there's more building and impervious cover than there is vegetation. Very different from wildland urban interface areas, right? And when we focus in on individual homes and individual neighborhoods, we see that that environment gets very complex. We have different types of species. We have different types of structural characteristics or heights, densities, spaces between the trees and shrubs. We have different types of ground covers, mulches. We irrigate, we fertilize, we have roads, we have impervious surfaces, right? It's just a very complex environment. So in these recent years, when we've had these neighborhoods burned, we've noticed some very different things that we hadn't seen in wildland urban interface fires. And we'll get into detail on what these observations have been, things we've noticed that are different. But as you all know, in these communities, we've been noticing a lot of instances where it's the homes that catch the vegetation on fire. That fire doesn't spread continuously across the landscape in the homes. It's ember driven. It's interrupted by roads, by buildings. There's different types of buildings. There's different types of folks living in these homes. So it's just a very complex environment, and it's very different than the wildland urban interface. So what's urban? We can use the US Census definition of what an urban area is. Depends on people counts, the number of people living in a certain area. We can also go with the number of housing units per unit area. And the US Census has done a very nice job of locating urban areas and rural areas in census tracts and in rural census tracts and in urban census tracts. Again, based on the number of people living there. In terms of the Forest Service, we define communities strictly based on the number of buildings per unit area. Nothing about the characteristics of those buildings, whether they're homes, barns, trailers, cabins. It's just the number of buildings per unit. That's how we define a community. So this is really starting to get very difficult, that we see that very different types of neighborhoods that are in urban area are starting to be affected by fire. This is a study showing the number of structures destroyed by wildfire in urban areas, major metropolitan areas, micropolitan areas, small town and rural. And what we see is that cities are starting to be affected more. And we'll show you some California specific numbers on this trend. So the way we have of dealing with vegetation in urban areas, as opposed to the wildland urban interface, we have a concept called urban forests, which are basically all the woody plants, all the soils in and around where people live. The state of California, through its California Urban Forestry Act, has a very specific definition, but I basically just summarize it for you. It's everything, all woody plants in and around where people live, regardless of land use, regardless of land tenure. It's all woody plants in the city and around the cities. And you can see how that kind of starts contradicting a little bit about this concept of wildland urban interface, which I'll get into shortly. Okay. But just like wildland fire folks and structural fire folks have been looking at this problem of fire, we've been looking at vegetation in cities, not only through research, but we also have tools. We work with landscape architects, horticulturists, planners to better understand how to manage vegetation around cities for the health and well-being of society. Right? So that's a difference probably we have in urban areas, that we focus on people's well-being, whereas in the wildland urban interface, it's protecting vegetation habitats and individual structures. Okay, so just a little bit of a different way of looking at things. So to make a long story short, the effects of fire in cities versus the wildland urban interface are very different. Plants in cities did not evolve with fire, very different from wildland areas where we do have flora that evolved with fire. In cities, we have non-native vegetation. In cities, fire generally doesn't have a lot of beneficial aspects to it. In wildland urban interface, we can use prescribed fire. And again, there's a long history of research and information on fire in wildland areas. In cities, we don't have it. So to start getting into some numbers and just how different urban areas are from wildland urban interface areas, here are 3 studies from 2020 and 2013, 2015, but really focus on that top one. This is a study they did in Los Angeles looking at plant diversity. And what they found, that compared to remnant natural areas, again, wildland areas, cultivated areas, i.e. urban areas, contain more exotic species. More than double the number of plant species are in urban areas relative to wildland areas. And then when we start looking at this vegetation in cities, we start seeing the role that humans have. One study in 2013 found that tree diversity was affected by the age of the neighborhood and household income. In another study at the county level, they found that a person's education was the best predictor of how many tree species were present in their yards. Okay, so again, very different reality in terms of the ecology of urban areas versus urban interface areas. This is a study we've just wrapped up with Tree People, where we went into 35 yards and we measured every wooded plant in a person's yard. It was 35 yards we measured. Some of the numbers we had, and as you notice, we went and measured everything: front, side, backyards. If it was a shrub, a tree, or a palm, we measured it. So what did we find? We found 325 different shrub species, 95 different tree species, and 7 different palm species in these 35 yards. We found more native species in more affluent, larger, older yards. Older neighborhoods had more trees and shrubs. Newer neighborhoods had more palms. Trees in neighborhoods were on average farther from the buildings than in older neighborhoods. That's relevant, as we'll see, to the zone 0 issues we'll talk about. And there were more trees in front yards on average than in back and side yards. Okay. So when you look at that upper left center box, that one that has 325 shrub species, when we look at chaparral species, this is a source I found. You might be able to point out a more relevant publication, but the Forest Service has a field guide for chaparral species. They've got 132 shrub and subshrub species listed for Southern California chaparral. Whereas again, just in these 35 yards, we found many times more shrubs and tree species. So when we start talking about the role of fire in different species and how those plants are maintained, where they're planted in cities, it starts getting very complex. Things in chaparral are also complex, but not as complex as in urban areas. And as you'll see, when it comes to fire, and the fact of the different types of people living in these urban areas, things can get very complex. Okay, so let's walk back a little bit, a couple of years when we started looking at this problem and trying to see how we could best inform folks through research. This happened again after Paradise and Santa Rosa. And we started seeing a trend that, again, that what we were seeing in these communities impacted by fire was very different than what we're seeing in rural areas and wildland urban interface areas. The folks being affected were different. The types of homes being affected were different, and the impacts were different. So we started looking at through research and trying to put our arms around this issue. Okay. So with this project, we were looking at the social and ecological dynamics of wildland urban interface areas. And this was more from a fire management, urban planning perspective. And then again, this started 6 years ago, right during when Zone Zero was developed. But we weren't a part of those original discussions. Again, these questions came up in parallel with how the policy was formed. We were interested in, vegetation moisture, vegetation density, the types of vegetation affect fire behavior in wildland areas. We assume that those same principles apply in urban areas. So let's look at that. So we use remote sensing, policy analysis, and economics to kind of address that question. Because people are such a big role in what's planted, where it's planted, where people build, how people build. We wanted to look at both the social and ecological components of this in a integrated manner. And that's some of the research I'll show you. Okay. So one of the first research projects we did, we looked at the neighborhoods that were affected by fire in Ventura, in Santa Rosa, and in Paradise. And UTC is urban tree cover. Okay, so that's the amount of tree cover a given neighborhood has. So we measured the amount of tree cover in these fire-affected neighborhoods, but we also looked at tree cover in adjacent neighborhoods that were not affected by fire. And we tracked that tree cover a year before the fire and 4 years after the fire. Okay, so FA, that solid line in the graph, that's fire affected. And FA, that dotted line, is non-fire affected. The error is when we had those fires. So basically what we saw in Ventura and Santa Rosa was that 2 years after the fire, tree cover recovered to the same levels as in adjacent neighborhoods that didn't burn. So we got a very quick response in tree cover recovery. Whereas in Paradise, we lost tree cover after the fire, obviously. However, that tree cover has been continuously lost since then. It has not recovered like in Santa Rosa, like in Ventura. Okay, so as plant enthusiasts, plant specialists such as yourselves, you probably think of why vegetation recovery in these neighborhoods in Southern California and near coastal California was quicker. We think it's because it mimics the adjacent ecosystems, that just like chaparral recovers fairly quickly after fire, so does tree cover in the Southern California urban forest. Santa Rosa, oak woodland, it recovered the same way in the city. However, Sierra forest, inland, colder, conifer-dominated forest, Once you lose that tree cover, it takes a long time for that tree cover to come back. So what do we learn from these? Every community is different. Every urban forest different, and they respond differently to fire. One other thing we noticed back then when we did this study was that a lot of this neighborhood that was affected by fire didn't fall within these wildland urban interface mapped areas. And we also learned that urban tree cover is very similar to the surrounding land cover and ecosystems. Okay, so that's kind of a first set of lessons we take. We also looked at the people side of how fires are affecting people and communities. That first graph shows the number of urban areas as defined by the US Census Bureau and the number of times they've been affected by fire during 2010 to 2020. What we see is a statistically linear increase. Every year, more and more urban areas are affected by fire. When we looked at the folks living in these census areas, we see that renters are increasingly being impacted by fire statewide. When we look at their income, we see it's not necessarily lower income folks that are being impacted by wildfire. It's property owners, middle class, upper middle class folks that are being impacted by fire. However, the ethnicity, the demographics of those homeowners is changing. This is one example in the coastal sage ecoregion, which is coastal Southern California, basically. There we saw that urban census tracts with large Asian American residents are increasingly being impacted by fire over time. And Hispanics in North Central California in the Klamath area are increasingly being impacted by fire. So what's the lesson here? Different demographic groups are being impacted by fire in recent years. So the way we communicate and message fire needs to be different, whether it's in fire mitigation or evacuations. We're currently working on different ways to communicate to these different demographics. Okay. And in parallel, another set of folks from our Forest Service office in Missoula came up with this conceptual work that pitched the idea that we shouldn't be thinking about these as wildfires, that communities like those in Los Angeles that burned last year, like those that burned in Lahaina, Colorado, even in South America, Australia. Even last week, I read that 100 homes had been lost in Norway. So what we're starting to see are urban conflagrations or urban fires. They're initiated by wildfires, by natural vegetation burning, but within a few minutes, it spreads to urban areas, and that fire spread from building to building, not from vegetation to vegetation to buildings, from buildings to buildings. And that's an important conceptual way of looking at this problem. Again, when we think of wildland urban interface, we bring back that body of knowledge that's been ingrained in a lot of us. And when we think of wildfire, we think of rural areas and natural areas. But if we start thinking about these types of events as urban fires, we start thinking about the urban ecosystem and cities. Okay. And what's interesting is the more we've looked at these events, and if we start reading historical accounts, this used to happen a lot in cities. Okay, whether it's San Francisco in the early 1900s, Chicago in the late 1800s, Europe, Asia, they episodically had these fire events in the city. Okay, so we'll talk about some of those reasons why we haven't seen those in a long time. All right, so wildland urban interface. It's a little bit kind of a complex PowerPoint, but the take-home message here is that this definition of wildland urban interface has been around for 20 years, 25 years, and it's strictly based on the number of building footprints that are present in the landscape relative to their distance to patches of natural vegetation. And then you use a very simplified rule in a geographical information system, and then you're able to map these areas out on the landscape. And that's been very useful for state, county level fire management. But again, when we look at urban areas and individual yards and individual neighborhoods, that concept really hasn't been holding up. Okay. So these are the definitions of wildland urban interface in California. There's 3 types in California: wildland urban interface, intermix, and influence. You see the 3 areas there in the Altadena area. But then when we look at that map and look at those actual areas that burned, a lot of that area went beyond this wildland urban interface. So some of the research we've been doing is we've been looking at those same methods that folks use to map out the wildland urban interface. But in our research, we've been including the amount of vegetation, but we've also been including that human component, the social component in terms of socioeconomics, education, income, but also governance, how institutions, how organizations interact with each other, and how they manage with fire. And we came up with this socio-ecological zone concept. So what we found was that in Southern California, if we factor in for all those realities, instead of having 3 wildland urban interface types, we came up with 27 different types of socio-ecological zones. And when we looked at that and looked at how many fires have been experienced in those areas, affected those areas, we basically found that vegetation cover alone and even vegetation biomass alone isn't the sole driver of wildfire. And to test this, we even tested the same model in southern Italy that has very similar climate and vegetation types, very different governance realities. But in a nutshell, we see that the wildland urban interface, it's not an overly simplified model. But again, when you bring in cities, it's very complex. Okay, so at this point, I'll take some questions.
Yeah, I mean, if people could put their questions in the chat, I would, and I'll kick it off, Dr. Escobedo. I'm really struck by your last slide with 27. Was that a surprise to you in your research?
It was. Again, this way of looking at wildland urban interface is really ingrained. But every time we went out there, we saw, well, what's a structure? I mean, I see homes, I see apartment complexes, I see hotels, I see trailers, I see RVs. The structure thing just doesn't match. And I mean, people are there. And it's just not simply the type of vegetation, it's how much vegetation is there, and what condition that vegetation is in there. So when we put all that together, it really made sense. I think that these areas are just very complex. And again, when you talk about that research that was done by folks at UC Riverside or UCLA, when they looked at the amount of plants in cities versus adjacent chaparral ecosystems, it really strikes you that, again, these urban areas are just very different. So I think in the second part of the presentation, I'm going to really make the suggestion, and it's been really helpful to me to not think about what happens with fire in chaparral as the same thing that happens with fire in cities, because cities are just more complex. We know there's information out there on chaparral, but not so much so on cities.
Yeah, excellent. So one of the things that I thought of in your presentation was Jack Cohen was also a guest at our UCLA science working group, and he refused to use the term wildfire when we were referring to Palisades and the Eaton fires. He calls them urban fires. And so there is a definite agreement between you all. And so I have a question that kind of begs this question. One of the strongest themes in your presentation is urban fires are fundamentally different from traditional wildland urban interface fires. Could you explain what you think policymakers and the public are missing when they continue treating them as the same problem?
So I don't mean to. So I have to be careful into getting into the policy side of it, right? We've gone through a really difficult time in the past couple of months. I'll leave it at that. So because this presentation is recorded, I'll I'll be very diplomatic in how I answer that. Okay. But if you notice when we use this wildland urban interface concept, it automatically, because we're trained to think about wildland urban interface in a certain way, when we throw the term wildfire or wildland urban interface management in these neighborhoods, I think like any human, we automatically start thinking a certain way. And we start taking the years we've had dealing with fire in these rural areas and we try to apply it to cities. And it's just not there. Okay. On the other hand, when we think about urban forestry and the benefits of trees, whenever you manage trees in cities, there's always trade-offs, right? Do you plant a native? Do you plant a non-native? Do you plant near a home? Do you plant far from a home? What is the fact that you plant a tree going to cause allergies to your neighbor? So now there's a new trade-off that we've got to throw into our equation, and that's fire hazard. Okay, so all vegetation does burn, but as I'll try to inform you later, we're trying to get to the point where we can inform that discussion so that we can tell folks that just because all vegetation burn, not all vegetation is bad. And because all vegetation is bad, it all needs to be removed. On the structural side, they've done a really good job of researching what building materials, what roof types, even the types of windows you have in your home, and how that reduces the likelihood of your house catching on fire. We think that in a few years, we'll be able to have that same information to be able to show policymakers, and folks like yourselves will have that information to show that if you plant certain species, you maintain them a certain way, you irrigate them a certain way, you arrange them a certain way, that minimizes your chances. It doesn't eliminate risk altogether. Neither does home hardening eliminate your risk altogether, but it does increase the chances of your home surviving. So that's what we're hoping to do with our research. Sorry for
Great.
the
No, great. And I'm hoping we'll get more into that maintenance. Ty Garrison has in the chat, it seems that the result is that the community demographics are influencing fire intensity, question mark, spread, question mark, ignition. Am I understanding that correctly?
So I think so. I'll show you some research where we've taken kind of that question on who is living in that neighborhood, the vegetation they have in that neighborhood, and how it's related to home loss.
Oh, no.
Okay, so we'll get into that. But I think it's an important question, and it kind of further emphasizes this concept that urban ecosystems are human dominated. Humans decide where to plant, where to build, how to build. So in a way, it is related, right? It all falls on us and how we maintain our landscapes, what we plant, but also how we build and where we build. So it is a people problem. When we get into the zone zero discussions, it's often phrased strictly in terms of buildings and vegetation broadly defined. What I always say, it's just not a building vegetation problem. It's a building vegetation people problem, and how people are informed, how they think, and what they decide to do or not to do with their homes and their vegetation. That's what makes a difference. And I think a lot of the earlier discussions were kind of excluding the people side from the discussion.
Yes, very interesting. I'd love to talk more about that. And I don't know, when I was in school at UF, urban ecology included people. So,
That's it. That's it. I mean, I showed you also my background that I started working off as a forester and firefighter. I used to map forests and soils and wilderness areas, and I worked in Alaska for a while. But I really liked helping people through nature, and that's why I decided to come and work in cities. But to work in cities, you need to know about people.
So Colleen Boy has in the chat I think she's talking about the mapped, the zones, is incorporated or unincorporated one of the factors that differentiates the zones?
No. Again, it's strictly the distance of buildings relative to patches of vegetation. That's it. There's interface, which is that kind of abrupt line between groups of buildings and patches of natural vegetation. There's intermix, where a building might be surrounded by continuous vegetation. And there's an influence zone that goes 1.5 miles from that area, and that's strictly based on ember transport. So no, it's strictly based on where and how many of those buildings are located in the landscape, their distance to contiguous vegetation, and then how far those embers can be transported. That's it. That's wildland urban interface.
Which kind of begs a question for me. Several of your slides distinguish between parcel scale and neighborhood scale predictors.
I'll get into that.
You're going to get into that later?
I'll show you
okay.
some slides that'll
Excellent. So I don't see any other questions in the chat, and I want to, oh wait, hold on. And I want to make sure that we leave time for all this, for your other part of your presentation. So you want to move to the next part of your presentation?
Sure. Let me load up that. All right, can you see it?
I can see it.
All right.
Yes,
all
I
right.
can
So
see it.
excellent. Okay, so I've given you the background, and I posed some questions, and hopefully I've given you some shared concepts and language that we both can use to that we all can use to kind of think of this urban problem and how it's different from rural and wildland urban interface issues. Okay, so these pictures were from Altadena and Pacific Palisades, and I think I've got a couple from Camarillo, from the mountain fire that occurred 2 years ago. So again, we're just seeing very different things. These fires are wind-driven. They're not continuous fronts of fire that move from the landscape into communities. They're very spotty, very regular, very driven by fire. We all saw that. When it comes to homes, and we think about this home ignition zone, this zone 0, when we go out there, we see that there's a lot of homes that are very close to each other. Obviously, many homes are within 5 feet of each other. And you know that there's a lot of homes within 30 feet of each other. And 5 feet, that's the definition of zone 0. 30 feet is the definition of zone 1. So when we think about that defensible space, home ignition zone, zone 0 concept, we really start seeing that this wasn't really making sense in urban communities. It makes sense in rural wildland urban interface communities, again, because these homes are surrounded by large tracts of land. In the city, not so much so. Some other things we saw: tree moisture, the vegetation, the height of vegetation of trees seem to be more important in how much that tree was affected by fire and how much that home and yard was affected by fire, more so than species or nativity. So what I mean by that, we'd go to these communities after fire. We go to these communities after fires impacted. We see a eucalyptus on one side of the street, another eucalyptus, same species, same size, on the other side of the street. One's burned, one's not. Usually what we've seen is that the one that's burned is in a vacant lot. There was obviously weeds, grasses, dead branches from the bottom all the way to the top. Parts of the crown were dead, so it burned. On the other hand, when we cross the street and we see that eucalyptus in a yard, it didn't burn. When we started thinking, why didn't it burn? It happened to be irrigated. It happened to be well pruned. So that really got us to think. So just because it's of a certain species or of a certain activity, there seems to be other things going on. And we'll get into some of the research where we try to kind of look at that reality. And then the other thing we were seeing, again, that really kind of just broke our conceptual model, was that it was homes that were igniting trees, not the other way around. And we kept seeing this, and we drive around. I take other people would come, and we'd all come to the same conclusion, is that It was the home that caught the tree on fire. That one image of that cypress between those two homes, Italian cypress next to a tree, it was the house that caused the tree to catch on fire. It's right next to a house, right next to the eaves, right next to the roof. The house is intact. Why? That's really interesting. And there you can see another example of a species that's reported to be highly flammable, pines, right? Same location, same size. The only difference in how much it was burned was its proximity to the home. And then another, these photos are from Louisville, Colorado. And what we're seeing there, and in places like Palisades, is that a few weeks, a few months after the fire, these trees start recovering. So should we be removing trees right afterwards? Or should we let them recover? And what was their relationship to the house that burned? Or why didn't it burn? So these are all questions we have, okay? So this is a study that we did a few months after January 2025. And again, this gets at the question of people, vegetation, the way we build, who's living in these homes, what their backgrounds are, what their income is, what language they speak. Because again, we could look at these in different parts, but we try to put all that together and see what patterns we could see. Yeah. So we were trying to see what the social and ecological factors that were associated with home destruction. And then the other thing we were seeing was that what happened in one yard might not be representative of the neighborhood. And what was happening in one neighborhood wasn't characteristic of what was happening in the entire community. So then we started looking at different levels or ways or scales of looking at that same problem, okay? And I'll get into that. So you all know the background of these fires, high winds after a prolonged drought period, a lot of homes affected, a lot of yards affected. So it was very difficult to go into these neighborhoods. We had no pre-fire measurements, but what we did have was satellite imagery. And there's a lot of Earth observation data from satellites, from airplanes, from other types of different technologies, and a lot of data in the form of maps that we can use to kind of try to understand these patterns, okay? So in this study, we used data from the US Census Bureau, tree cover from the Forest Service, fire frequency, fire maps from CAL FIRE. We used property appraisal data from CoreLogic, from Zillow. We looked at building footprint maps. Because US Census Bureau looks at large areas of large communities as a whole, not individual homes. We used a model that estimated the ethnicity of the homeowners based on last names. We came up with not just what that building was made of how it was constructed, but how much space that building took up in a neighborhood and in a community to see if that was influential and how much home damage there was. And then we used methods that are used by statisticians, by geographers, and economists. We call it econometric modeling. That's statistics for economists. We used damage inspection data. That's the data that CAL FIRE collects after these fires occur, where they go in and assess the home for levels of damage and probable reasons behind why that home was lost. And then because we had the footprints and we knew the level of damage in those building footprints because we could assign it to a specific home, we could then put in zone 0, zone 1, and zone 2. And then we could bring all that in with maps, geographical information systems, and we could map out patterns of home damage for both Pacific Palisades and the Eaton fire. So some kind of big picture results. In Pacific Palisades, we found that 15% of homes had another home within 5 feet. The average home in Pacific Palisades had another 2 homes within 30 feet. And very similar numbers in Eaton and Altadena. So thinking about zone 0 and the amount of vegetation and what removing that vegetation within 5 feet means when you have another house within 5 feet. Again, that really brings into question that model, right? And then when you have another 2 homes within 30 feet, zone 1, that really brings into question that model. But then we also saw that the demographics were slightly different. The language that folks speak is different. We obviously knew the income differences and the amount of resources that each community had. But this adds, that emphasizes or reiterates what we've seen in other communities and in other studies in California, that every community is different. Even within Los Angeles, different neighborhoods, different communities have different social and ecological characteristics in terms of tree cover, in terms of the people that live there, the value of the homes they live there, and how those homes are arranged on the landscape. Okay. All right. So these are neighborhood level characteristics. So we looked at neighborhoods in Pacific Palisades and in the Eaton fire, Altadena, Sierra Madre, and Pasadena. And these graphs, if you look at the vertical axis, it's the level of home destruction. As you go up, it's more homes destroyed. Okay. And there's 3 boxes. So let's focus on those top 3 boxes. The black box shows the amount of footprint area, how much space those homes take up in neighborhoods in Pacific Palisades and Eaton. And what we see is that the more space those homes take up per unit area, the more damage you have. And that makes sense. The closer those homes are to each other, the more homes are going to be lost because of fire. If we then jump over to the red box, we have the level of home damage, but then we have the number of homes within zone 0 in that horizontal axis. So what we see there for both Eaton and Palisades is that the more homes you have within 5 feet of each other, the more homes are going to be lost. That makes sense, right? Pretty straightforward. And that's what pretty much all the research that has been done regarding urban fires and wildland urban interface fires show, is that the closer the distance between buildings during these urban fires, that's the main driver of home loss. Okay. But then we looked at tree cover in both Altadena and in Pacific Palisades, and we got this really conflicting result. Okay. Again, vertical is tree loss, horizontal is the amount of tree cover. So what we saw in Pacific Palisades is that the more tree cover you had in a neighborhood in Pacific Palisades, the less homes were damaged. In Altadena, we saw the opposite. The more homes, the more tree cover you had in Altadena, the more homes were lost. Okay, so completely different trends and characteristics. That the more tree cover you had in Altadena, the more homes were lost. Right? The more tree cover you had in Pacific Palisades, the lower the number of homes that were lost. So very complex results, right? Not straightforward. However, what we do see is that buildings and the way those buildings are arranged across the neighborhood, that's the main driver. Okay, so this was looking at neighborhoods in Pacific Palisades and Altadena. Okay, so this is another really complex looking graph, but look at that black box and that red box. Okay. And when we looked at tree cover, at individual homes and individual parcels or yards, and then we looked at tree cover in individual neighborhoods, we saw that those trends matched, right? For Pacific Palisades and Eaton, right? In Pacific Palisades, the more tree cover you had, the less home damage. In Eaton, the more tree cover you had, the greater the damage. However, when we looked at structure footprint area of individual yards versus the amount of building footprint area at the neighborhood, we got opposite results. When we looked at neighborhood level data, we got a positive relationship between home loss and the amount of building footprint areas. When we looked at yard level or parcel level and the amount of structure area, we got a negative relationship. So the take-home message here is that depending on the type of data you use and the scale of data you use can tell you very different stories, and you can find very different relationships. Okay. All right. So those were neighborhood level impacts and parcel level impacts of the Altadena, of the Eaton and Palisades fire. So now let's look at individual tree effects. So this is a study we also started right after January 2025, but here we used tree inventories from the city of LA and the county of LA before that were done before the fire, and we then went and located those trees after the fire, and we took different sets of measurements. Okay, and we were trying to answer two questions: how were different tree types and species affected, and how did tree height, the size of the crown, and nativity, how was it related to how much they were impacted by fire? And then we were also trying to come up with a method of assessing fire and its effects on urban trees. Remember, we know a lot about wildland trees. We don't know a lot about urban trees. As you can see, it was a real team effort. Folks from the University of Florida, UC Davis, UC Extension, UCLA, LA County Master Gardeners, and California Climate Action Corps all helped us collect this data. So this data we collected on rights of way, on public rights of way. We couldn't measure every single tree, public tree in Palisades or Altadena. So we selected representative quadrats that had the greatest number of trees, so we could capture the greatest number of trees that were affected by fire. FIA, that's Forest Inventory and Assessment Method. That's how we inventory and assess the amount of forests in the United States. So these are measurements we take in wildland areas, but we adapted them to urban areas. A lot of the measurements we take for post-fire effects in wildland areas, we adapted them to urban areas. And then we use statistics to look for relationships. Okay, so that's us right after the fire, doing some measurements on trees. We measured the amount of scorch in the crown, how much that crown was singed, how much of that crown was consumed, that all the leaves, all the fine branches were completely consumed. We looked at the stem of the tree, the trunk of the tree, to see how much it was charred and how deep that char was. And then we measured where that fire effect was in the upper crown, upper stem, lower stem, or in the roots. Okay. So we measured about 1,500 trees in Altadena and another 500 trees in Pacific Palisades. I'll show you some results for Altadena. We used non-metric multidimensional scaling and Bayesian regression. Fancy words, but basically we're trying to look for patterns regarding the type of tree, the species of trees, characteristics of the trees, and how much they were burnt. Okay. So what did we find? We found that fire doesn't differentiate between native species or by species. Where we did find relationships was trees that had higher crowns that were higher off the grounds. Those were less damaged by fire. And when crowns were wider, they were more damaged by fire. So nativity didn't matter. The type of species didn't matter. But the structural characteristics did matter. And, you know, a little ahead of myself, through maintenance and management, we can manage for crown heights and crown widths. So keep that in mind as we start talking about practices for zone 0. Okay. All right. So let's get into some research where we try to test what the role of vegetation in zone 0, zone 1, and zones 2 were on building loss. As you all know, there's a body of research from mechanical engineers and fire scientists that build models in warehouse using different materials. They blow embers into those buildings, and then they see what configuration of building characteristics at night and catch on fire, basically. They've recently been trying to do this with vegetation. There's another set of studies primarily done by landscape ecologists and conservation biologists that use remote sensing satellite imagery, and they looked at whether that building was lost and the landscape characteristics around those homes. And for this, they used satellite imagery that had what we call a resolution. It covered 30 square meters. So they look at the landscape in terms of squares or pixels that are 30 square meters in area. So that's equivalent to over 300 square feet, right? And then they look at the relationship between whether that building was lost or whether it was survived, the amount of tree cover, the slope, the wind characteristics, the proximity to other homes. Okay, so 2 lines of research. So what we see here on the first side is that these are very controlled experiments, very different from the complexity we see in this neighborhoods that were burned. From the research that other ecologists have done, we've seen they use landscape ecology and a way of analyzing wildland fires that's very different from urban fires. And the type of satellite data they use is very broad, very coarse, right? We know that in yards, urban landscapes, parcels are smaller. And as I showed you in that study, yards are very diverse, very complex. So we needed a different way of looking at this. Okay, and then you know all this about zone 0 and its importance. Okay, so what do we do with this study? And again, we started this study in 2021-22, and we published it in 2025 last year. Okay, so the way we looked at this problem, we took that same approach of looking at buildings and whether they were damaged or survived, and looking at their environment, the context around those homes, but we did it at a finer scale. Okay, so what we did, we took satellite imagery from one day before the fire or the morning of the fire, and we looked at 1,230 different parcels or yards in Ventura and 16,319 yards and homes in Paradise. Okay, so we then took that yard, and using satellite imagery, we mapped the different types of vegetation around each home in its yard. We then classified the different types of vegetation around these homes. And then we measured the location of that vegetation relative to the home, distance of that vegetation relative to the home, in these 3 zones. This table shows you all the things we were able to calculate for each of those homes in Paradise and Ventura. Tree cover, forest cover, shrub cover, herbaceous, vegetation moisture, the direction of trees, the direction of herbaceous, the direction of shrubs, the amount of overstory tree cover over a home, the distance between the building and the trees, the type of building, the density of buildings, the roof types. On the right, you see how we classified the vegetation around the homes. If it was vegetation, we differentiated whether it was shrub vegetation, groups of trees, or individual trees, or herbaceous. And if it wasn't vegetation, we separated that out into bare ground and into buildings. We used that damage inspection data from CAL FIRE that measures post-fire, where crews go out and assess the level of damage to homes. And we were able to map out zone 0, zone 1, and zone 2 around each home. But then we took this technique that's used in agriculture to determine crop stress using satellite data, and we applied it to these same yards. And we looked at water stress around these individual yards, around these individual homes. And we were able to get a measure of vegetation water stress. And this is kind of similar to what we do in wildland areas when we look at fuel moisture indices or drought indices, because that really affects fire behavior. We assumed that we were going to see the same thing in cities, that the drier the vegetation, more likely that the home was going to be lost, right? The greener the vegetation, the harder it is for that vegetation to catch on fire. And if it's harder to catch on fire, there's less likelihood of that house being burned. We use this advanced, this complex statistical approach. We work with a PhD statistician to develop this. But it basically takes all those measurements, puts them into a statistical model, and then maps out the relationships between those variables and comes out with an outcome. The outcome being, did the house survive or was the house lost? Okay. We used two statistical models, one for Paradise to represent Northern California, another statistical model for Southern California. Again, because what we've seen in past research, communities are different. Northern California is very different than Southern California. Therefore, we should look at things in a different way. Okay. So there's a statistical model for Ventura in zone 1, and then a model for Paradise in zone 3. Okay. So each city, each zone had its own statistical model, so we can look at all this relationships going on with all these things we mentioned. All right, so what did we find? So this list shows the most influential predictors listed in order of importance that were related to building loss. In Ventura, that represented Southern California, and Paradise, that represented Northern California. So what we see in Ventura was that in the first buffer, in zone 0, the two factors that were most related to building loss were low bare ground cover and low tree moisture. Okay, so that makes sense. Buffer 2, low herbaceous moisture, low shrub moisture, and the distance between trees. In buffer 3, it was bare ground, but there we see building density come into play. But when we turned that statistical model around and we wanted to see which buildings survived, we found that in terms of vegetation, the top two predictors of the building surviving were high bare ground cover and high tree moisture. So we thought that was really interesting, right? However, when we looked at moisture in Paradise, moisture did not really come out as an influential predictor in Paradise. It was bare ground, distance to bare ground, distance to herbaceous, and the amount of overstory tree cover over that home. Those were the 4 most influential predictors of home loss in Paradise in Northern California. In buffer 2, though, we found that shrub moisture and building density were the top 2 factors associated with building loss. And in the third buffer, it was the distance to trees and building density that were most related to building loss. Okay, so to wrap up this presentation, these are kind of the take-home messages I'd like for us to leave with. That in a lot of these discussions around Zone 0, the engineers, the wildland firefighters often use the term vegetation as something like structure, as something like number of evacuees. Very broad, not very specific. However, as I hope I've shown you, vegetation in cities, in urban areas is very complex. It's very diverse. There's different compositions, there's different structures, different densities, different moisture levels, different types of maintenance that go on, okay? And that's not being accounted for in a lot of this discussion. More recently it is. When this discussion first started, they were not. And again, it's important that we have these discussions. We think about urban ecosystems and urban fires. There's fire in the chaparral, but we should think of chaparral ecosystems in that. And when we have these discussions, okay? In terms of building characteristics in Zone 0, we've seen that relationship is direct. All the literature, all the studies have shown that the more buildings you have per unit area, the closer those buildings are to each other, there's a direct relationship with home loss. The relationship of vegetation and the different types of vegetation and the relationship to home damage is really complex, as I've shown you, at least in the LA fires. The other reality is that all vegetation burns, okay? However, I think what we're starting to see is, depending how that vegetation is maintained, how that vegetation is irrigated, how that vegetation is arranged in the landscape can really make a difference. So what we're seeing is that it's not really species of vegetation or whether the species is native or non-native. It's how we maintain and how we arrange that vegetation around the landscape. Okay. Finally, to kind of wrap up, I mentioned this at the beginning. When we started doing this research in these communities, we kept using the term unprecedented. But in reality, if we think back again a couple of 100 years ago, we see that these same types of events used to occur. There's a picture of Altadena in 2025 and a picture of San Francisco in 1906. So very striking similarities. Although we haven't tested this yet, and from what we've read, everything seems to show that the reason we've stopped having those urban conflagrations is that we started building different. Started using bricks, our gas water infrastructure improved, and our firefighting technology improved. However, with climate change, with us building in certain places where fire is more common now, we're starting to see this problem again. Really quickly, some of the research we're doing, we did some surveys in some foothills communities to see if people can differentiate smoke from prescribed fire versus wildfire versus regular pollution. They can't. That's some of our preliminary results. We're funding another study with UC Davis that are looking at plant flammability, specifically how different plant litter ignites and sustains that heat and causes all these other bad things. In April 2025, we had a workshop. We brought in a lot of experts, a lot of environmental organizations, and we talked about this urban fire concept. And then we also have in review a extension manual. We're calling it a post-fire urban forest restoration manual for Western urban forest. So we came up with some guidelines and practices for homeowners and for communities on what to do regarding urban forests days, weeks, months, years after the fire. We walk them through the whole process, and this is based on the experience we've had with several communities. Another neat project we're working on, we use light detection and ranging. So this is a ground unit where we're able to model landscapes in 3 dimensions. So if you notice that image there, this was taken a few weeks after the Altadena fires. And what you can see is that in 3 dimensions, we can map out the ash print of a house and the location and the level of damage of trees, palms, and shrubs around those homes. So we're currently analyzing that data. Dr. Alessandro Sola, UC Davis, and Edith de Guzman from UCNR, UCLA are leading that study. That's it. That's my email. If you have questions, feel free to email me.
Thank you, Dr. Escobedo. I mean,
thank you.
Hey, Roger, Dr. Escobedo, do you have hard out at 8:30 still?
No.
Okay. So the chat is open for questions. I'm not seeing any. Roger, unless you have one, I have a couple questions if we're waiting for questions to come in.
There was a question earlier in the chat that Colleen had asked about the zones and unincorporated and incorporated, one of the differentiations, and I think the question was not completely answered. I think she was asking about, Altadena being an unincorporated LA County as opposed to Palisades being incorporated city of LA. I think that was the distinction she was getting at. What if that
Okay, so
went into your 27 odd different zones?
okay. So the answer is still no.
Okay.
Regardless of tenure, land cover type, government type, if it's building footprints and continuous patches of quote unquote natural vegetation, that's the criteria. And I think it's been really helpful for state level planning, maybe even county level planning, but local level, I find it really needs to be improved.
Okay.
Because things are just more complex, right?
And Ty had asked a question in text that was primarily answered in text, but had the 5-foot clearance and zone 0, and the comment about other homes being within the 5 feet. And did we find in Altadena that houses were closer than 5 feet to each other, proximity?
So what was it? 17% of all homes in Altadena had another home within 5 feet.
Meaning that they did not have 5 feet clearance between the house and their property line.
Yeah.
Okay.
So if you try to remove all combustibles, that's how fire reports within 5 feet.
Yeah.
You've got to remove other homes. That's not going to happen. Right. Yeah. So the logic there. And then again, every home on average had 2 homes within 30 feet. So it's not going to happen.
Yeah.
Lesson number 2, it's building space that drives building loss. Vegetation is really low on the list, right? Lower on the list.
Right. Right. Proximity of structures is the primary driver.
That's it. All
Yeah.
studies show that.
Okay, there was another question more recently in the text. Um, Casey Young asked, any definitive research on coast live oak trees with protecting urban structure from fire? And I think we've heard the term coast live oaks being ember filters.
Yeah. So I think Travis is trying to make that, is trying to test that. What we saw based on our data and our preliminary results, we don't know about the ember filter function, but what we did see that a live oak will catch on fire just as easy as a eucalyptus. It depends on the crown characteristics and, inferring from these
Hydration.
other studies, the moisture.
Hydration, yeah.
So,
Thank
so,
you.
so I think it's tenable, right? I think it makes sense that if a well-maintained green tree, post live oak or another tree, is catching embers, putting them out, rather than them landing on your roof or going into your attic vent, that's a net plus.
Yeah.
But no, that has not been tested specifically. We can infer it, but we can't test it. However, I want to really emphasize, as much as we'd like to think that this is the case, all vegetation burns. We've seen cars catch on fire and drive out. So if it gets hot enough, anything's going to burn.
Yeah. Yeah. Thank you. Next question, Dave Coons asked, has there been any study of the building materials or design that have the impact on fire damage? Stucco versus wood siding.
Yes, countless studies. Countless studies.
Okay.
Well, I would say countless. There's a lot. The insurance, what is it? The Insurance Institute for Business and Home Safety. They've done a lot of that. UC Agriculture and Natural Resource Extension, specialist called Quarles, Stephen Quarles. I think he's done a lot of research on that. So there's a large body of research on what to use in homes to reduce the likelihood of it catching on.
Thank you. And then, yeah, Orchid mentions cars are actually quite flammable.
So it's amazing. I've seen cars in driveways that caught on fire and the house is intact. And
Wow.
what happened?
Yeah. Yeah. Okay, Susan writes, our home in Altadena is a standing home, a block south of fire perimeter, but also in what looks like a downward shadow of Christmas Tree Lane, which is tall deodar cedars,
Yeah.
as seen on the Eaton DINS map. And the talk of the neighborhood has been about whether we were protected by the deodars of Christmas Tree Lane.
So that that was a discussion a day after, right? One thing has been a factor. I think the study from Cal Poly Flow kind of looked at that, is the role of wind, that trees might have a filtering effect, but they also might have a wind obstruction effect. So that's also the problem we have in urban areas, is that because they're very complex and our wind data is very broad, we can't really know exactly what happened in that line of home, those two rows of homes downwind from Santa Rosa Avenue, right?
Right.
We just don't have that type of data, but it would be really interesting to look at that. And we don't know. I mean, speculative, you could say that.
Okay, Dan and Nicole, you had your hand up for a minute. Did you want to
Just
speak?
put the question in the chat. I can read it. Dr. Escobedo, what's the biggest unanswered scientific question after the 2025 fires? What do you think researchers should be studying next?
So this came up earlier about the role of people. We can use satellite imagery. We can go in and measure stuff after it happens. I think what's really needed is to understand what people did the day of or a week before the fires in terms of their landscapes, what was on those landscapes. It's very hard to do because you don't want one of these, right? It's very difficult to know what neighborhood's going to burn and you go there and set up and start measuring stuff. But I think you can do surveys interviews. There's been a couple of undergraduate students that have they've done surveys based on small samples with homeowners in Altadena. But I don't think that's a robust enough way of trying to capture exactly what folks were doing with their landscapes, what types of folks were doing certain things or not doing certain things. I think that would be really helpful in terms of education. The world of wind also, and directly testing that role of amber filtering by green, non-stressed tree crowns on buildings that had certain characteristics. So that's another one. You know, and some of the engineers have tried doing that, but I think because they're engineers, they think of vegetation as building materials, and they just say vegetation. So whether it's a live oak or a cypress, they approach it the same way, and it's not, as we know. So I think that's the other question: is controlling for all things. How does the individual plant and its characteristics in terms of the amount of leaves, the amount of live material versus dead material, how that influences damage to homes?
Thank you. There was another question. Catherine Gallagher asks, if we have native plants in our yard that we rarely water versus non-native plants that people dump water on, are we incentivizing people to irrigate? And what is the alternative?
So, you know, again, I guess it's, again, plants. What do you mean by plants? Succulent or evergreen or a deciduous? So that's the other thing with native, with oaks, for example. If you have a deciduous species versus an evergreen species, what we saw in Pacific Palisades and in Altadena, that a lot of these species didn't have their leaves. It was leaf off. So we don't know what the crown impacts were, or crown effects were, because there were no leaves. So again, I think you have to ask that next question. This native plant with these characteristics, with these types of crowns, what effect? In terms of the watering, that's a trade-off, right? I think water use versus sustainability versus allergies, and now fire hazard. I mean, that's central to urban ecology, right? And the way we manage urban forest is that we try to account for all those trade-offs and try to pick the right plant for the right place for the right purpose, right? And try to minimize all those negative trade-offs. But that's a very difficult question. And ultimately, because it's, as we saw, the yard level is really influential in what's going on. Every homeowner gets to decide. There's ordinances, there's regulation, but it's ultimately up to the homeowner to decide what they do or don't do in their yard.
Yeah, and actually my comment to that is that it's typically very requires a lot less water to properly hydrate a native plant than a non-native, just kind of categorically in
So
general.
you know, and then the other way I've been looking at it is also is like, okay, if you plant a tree, we're not asking you to flood irrigate an almond orchard. A lot of
Right.
organizations have looked at the actual amount of the cost of watering a tree. It's not that much. I think it's equivalent to a couple of bottles of water or something like that. So it's really not a lot to maintain it healthy.
Yeah. Okay, next up, Diana, Nicole, you had your hand up, and then Orchid.
Yeah, thanks. I just wanted to mention, so there's a study by Keeley and Rubens, and I forget the other folks, sorry, scientists on the study that seems to be not very well known. And I was wondering if you were familiar with that study, but it speaks to what you were just talking about,
I
where
am.
the chaparral, where they slightly watered them through the summer and found that they reduced their I don't know if the right word is flammability. Yeah, I'd love for you to speak to that if you're familiar
Okay,
with it.
so that's something very interesting. And the one that so we've been recommending against using these flammability plant lists. They're one set of information, but again, thinking back about that example I gave you of those two eucalyptus, one in a well-maintained yard, one in a vacant lot, same species, same size, they're just going to burn very different because of moisture condition, because of maintenance. So I think in chaparral, if you look at, if we put our wildland hats on. If it's recently rained, there's going to be a high fuel moisture. There's going to be a very low likelihood of ignition and fire behavior, as opposed to it being in December when it's completely dry, hasn't rained, windy, right? So I think that's a general principle that can be applied to urban landscapes as well. And I think what that other study did also, they looked at wind, I think. And I think he's a, not Keeley, but the other, I think he was like an engineer, an aerospace engineer, I think that now has a
Yeah, Greg Rubins used to have a life in aerospace engineering.
Yeah, that's right. Yeah. We've had these discussions.
Kathy Sturdivant has posted the link to that publication in the chat here. So for everybody else, it's can get to that. Orchid, you had a question and hand up.
So Dr. Longcourt said that for a lot of us who are in the fire zone, and I'm in very well-watered oak woodland, and so my house is still standing in the bottom of Sierra Madre Canyon. And the only structures that burned were up on the edge, not down on the floor of the canyon. And I thought that was interesting. Two structures. But I went to Dr. Longcourt's talk 2 weeks ago, and he said that that there is no fire ecologist speaking that the Board of Forestry has on staff, or that they even recognize it as a science, that they only understand like fire science, like if you light something on fire, how does it behave? And they don't understand fire ecology as a science that we all, of course, are right in the center of, and of course you even more so. So can you speak to that?
Yeah, so not in their defense or necessarily talking bad about them, but again, as I said, I've worked a lot of years in fire, and I've worked a lot of years in these urban environments, and there's not a lot of information. I mean, what's happening is new, so there aren't a lot of experts. I think one of the issues is that you're having experts that work in wildland areas and that work with building combustion are trying to speak to how urban landscapes behave with fire, and they don't know. I don't know a lot, and I've spent a lot of time looking at this, so I think that's the issue, is that there is a science in urban ecology, but because fire hasn't occurred a lot in urban areas, it just hasn't been studied a lot. I know that this is going to be very different 5 years from now, just given the number of people that are doing research in this area. Again, I mean, 100 homes were lost in Norway last week. This stuff happens in Australia. This stuff happens in Spain. So when I talk to my colleagues from other parts of the world, they're also looking at the same issue. So I think in 5 years, we are going to be able to say we are a science. I showed a couple of little cutouts from articles, and that's exactly to speak to these types of folks that we can publish in Nature as well. We can publish in high impact factor journals as well. And in fact, when I've had discussions with his engineers, we sometimes get on who's got the higher impact factor, and I can tell them I do. I've got more. Let's have that conversation. The difference is I don't go to Northern California and tell them how to do prescribed fire, and I don't go to Redwood Country and tell them how to do prescribed fire. Yet they want to come down here and tell us how to manage plants and seeds. That's our area. I'll leave it at that.
Thank you. Diana asks if you could redesign a neighborhood after the Palisades or Eaton fires, what changes would you prioritize first? Would you focus on buildings, vegetation, infrastructure, or something else?
Buildings and
Buildings.
Then vegetation.
And building, what aspect of building would be most important? Location, proximity,
so that's
type stuff?
So in an ideal world, I guess you'd compensate folks sufficiently so they wouldn't build there. That's not going to happen, right? So I think if you know, from an economist perspective, if you gave them a certain amount of money and how they could use that money, I'd recommend they do attic vents, eaves, siding, remove all combustible, and then take it down from there. Vegetation somewhere in there, and again, I think in a couple of years we'll be able to tell this type of plants, this maintenance regime, plant them here and here, and you'll be okay.
Uh, and Diana just posted a bunch of stuff in the chat. I don't know, Diana,
I
if you
yeah, well, I won't, we won't read it. I just want to emphasize, Dr. Escobedo, I think you touched on this in your presentations on one of your slides, and we just touched on it. There is a difference between simulations and lab studies, and the work that Dr. Escobedo is doing. I mean, it's gold standard. And I just want everyone to understand that both important,
That's right.
but gold
Both are
standard.
important.
Yes. The other thing is that since we touched upon this, I think the distinction between the problem with the simulations, I'll just say this, is that unfortunately that gets used to make policy more than the peer-reviewed post-fire analysis, the studies like you just presented to us tonight. And I think that's important for people to recognize. And uh, and so, well, I'll just leave it there. But yeah, I have a lot to say about that, but I think it's important that so I just put that kind of distinction in the chat, and for anybody to read or copy and paste if they want to. And I just end with this. So there's an advisor to the Board of Forestry's Zone Zero Committee, which is made up of foresters and no urban foresters, no fire ecologists. And this came up. So in the work that I've been doing for decades as an ecological land care specialist, and I have a degree, a master's in plant science, maintenance is something I've been stressing in my comments at these workshops that have been done by the Board of Forestry as they're working on the Zone Zero draft. And it did come out a couple times by their advisor that the public can't, they didn't say this exactly, but we can't enforce maintenance. And so we're dismissing maintenance. And I'm so glad, Dr. Escobedo, that you brought that back in with your work. And because I think it's a big mistake, whether it's in whatever the species is, maintenance matters. And I don't know if you have anything to say about that, but it's really alarming to me. Also, just I find it a little offensive that we're going to just say, hey, the public can't be trusted to maintain their landscapes.
Yeah, so I mean, not only as a government employee, but as a scientist, I probably shouldn't be taking a policy stance, right? It's a very wonky, bureaucratic response. But I think if I were having a discussion with a wildland firefighter, they do field treatments, right? Where they basically manage vegetation, the amount of vegetation. And when they do that, they manage for the average type of condition, right? When you have these extreme events, you can throw a lot of that out the window, but on average, if you do certain things with vegetation, you can mitigate fire and you have a way to access it where you can bring in all that, all the things that firefighters do. I think if you apply that in cities, a lot of that is in line with the way wildland firefighters think. You have home hardening, you can have landscape hardening. You can provide for firefighter safety access. In wildland firefighting, we use north exposure riparian areas as safety zones. Why? Because they're wet, they're green, because they mitigate.
Really hydrated.
Why can't you use similar areas in the neighborhood? Something like that. Again, when we have events like we did January of last year, it's a lot of these relationships just get kind of diluted out by just the magnitude of what happened. But I think on average, we can do certain things to mitigate them. And I think by taking this scientific approach, even though it's slow, I can't speak in those Board of Forestry meetings, but hopefully you guys can take our research and show it. I think we're chipping away at that attitude that, oh, they're just tree huggers. Oh, they're just, you know. No, we're scientists. At the beginning, my hypothesis was that, yeah, vegetation near homes catches homes on fire, you lose. That's what I learned, you know. Working in cities, I know things are a little bit different here. And yes, after these fires, I've been seeing different things. When I have one-on-one conversations with fire folks in the same language, I think a lot of them get it. It's these folks that don't have experience in these environments. A lot of folks from Northern California, it's they don't get it sometimes that things here are just very different than
And
places
in
that are
yeah,
greener.
yeah, and policy doesn't do nuance. That's the
No,
real
no.
hard thing, right?
You
And
know,
I'll just say,
with homeowners also, nuance is difficult with homeowners.
yeah,
Right? You need broad take-home lessons, elevator pitches, and these are very complex
but I
environments.
was,
And the thing I like to think about in the context of modeling versus after the fact, what really happens is, in theory, there is no difference between theory and practice.
Right.
The real world is not a theoretical world. There are real factors that you might not model because you don't know about them, and that's what you're discovering.
You know, I guess the other thing, a conclusion I've taken away from all these discussions, um, because of my educational background and again working in these kind of urban space, you're never the expert on any one topic. You depend on other disciplines and other groups and other folks to kind of help you come to a solution. Engineers are trained different, I think. They're just kind of wired different. So I think that now that they're working in these very complex environments, they have a hard time with complexity. We embrace it. They have a hard time. So they try to control for it, which is good. That's what you do in an experiment and in a laboratory setting. But right. So that's their advantage, that they control for all these things and they can really zoom in on the factor. For us, it's always multiple factors and things aren't cut and dry. So I think we're
that
learning to communicate with each other, but it's sometimes
it's
not.
an excellent point. I worked with Disney Imagineers for years on the parks. So I know exactly what you're referring to, Dr. Escobedo. And there's one other thing I want to, and maybe I made this up in my head, but in reading your research on, you use the term droughty landscapes. Was that correct?
Yeah, we borrowed that method from crop science, and that's what they use, right? But it's basically water stressed, dry, stressed, so it's more combustible. If I would have written for a fire audience, I would have said fuel moisture level, right? They would have, but then urban folks wouldn't have been able to relate. Plant folks would have been able to relate to it. So one thing we're trying to do right now is we're trying to bring in other measures of moisture, pre-fire moisture, using other types of remote sensing. So we'll try to work on that. Different methods to measure different characteristics of moisture, and we'll try to communicate that a little bit different.
Well, thank you all. Thank you very, very much. Really
No,
appreciate your
we
sharing
can't
with us,
go. We
Dr.
can't
Escobedo.
let Dr. Escobedo go.
Got to keep on it.
Put you in my pocket. And I don't know if Roger, you want to do an update. There was a meeting today on Zone Zero. We can save that for another time. I'm happy to come
Yeah, we
back and
probably should say that for another time since it's now almost 9 o'clock. Let people go. So, and thank you all those who attended for sticking with us till the end. And yeah,
Roger.
yes.
So I did put our channel. This is being recorded and it will be posted on our YouTube channel, and that is in the chat. So save the chat if you can. Dr.
Yeah.
Long's talk is in there. And if you want to go to the Iris Hartweggy talk on the 5th, you have to email Jeff Chu, so that's also in the chat, so go find it all. Thank you so much, Dr. Escobedo. I appreciate you.
Thank you. Good night, everybody.
Good night. Thank you.
I second what
Thank you.
Orchid said. We appreciate you. Thank you.